Let's take a look at graphing from several perspectives. The instructions here say graph using the intercepts. So remember that graphing using the intercepts is a method where a table of values can be useful, because remember the intercepts, plural, means we have something crossing the x-axis and something crossing the y-axis. So when it crosses the x-axis, the y value is 0. When it crosses the y-axis, the x value is 0. So it might be handy to make a table of values and let's choose a 0 for the x value, and then we'll follow by choosing a 0 for the y value. Now we're going to use those zeros in the appropriate place one at a time and solve for the other values. So 2x plus 3y is equal to -6. We're going to replace x with 0 plus 3y is equal to -6. 2 times 0 is 0, so that leaves us 3y is equal to -6. Divide both sides by 3, and we get y is equal to -2. So y is equal to -2 when x is equal to 0. And we'll repeat the process now to substitute 0 for y and find out what we get for x. So we could now rewrite the equation. 2x plus 3y is equal to -6. Remember, this time we're going to replace y with 0. 2x plus 3 replace y with 0 equal -6. Well, 3 times 0 is 0. So we're left with 2x equal -6. Divide by 2, x equal -3. So when y is 0, we get -3 for x. Now that gives us two ordered pairs, and we can graph the line, with 2 points. So we're going to mark our 2 points. 0, -2. So 0, -2 is our y-intercept, and -3, 0 is our x-intercept. Okay. Right, and now we get a straight edge and we connect those points, and we have graphed the equation using the intercepts. Okay. All right, let's practice that again. New linear equation. Let's graph using the intercepts. So we remember that a table of values is useful to find the intercepts or to keep up with the intercepts. So table of values, x and y, and remember that the intercepts, we once have a 0 for our x and a 0 for our y. So let's say what the other values will be. 5x minus 2y is equal to 10. And first we're going to replace the x with 0. 5 times 0 minus 2y is equal to 10. 5 times 0 is 0, which leaves us -2y is equal to 10. Divide both sides by -2, and we get y is equal to -5. Okay, let's repeat the process now and substitute 0 in for y. So let's say that was 5x minus 2y is equal to 10. 5x, and we're going to replace y with 0. Well, -2 times 0 is 0, so we're left with 5x is equal to 10. And we divide both sides by 5, and we get x is equal to 2. So when y is 0, x is 2. Now we have two ordered pairs. We have our intercepts that we can mark, plot our intercepts. 0, -5, 0, -5, and 2, 0, 2, 0. Okay. And now that we've marked our intercepts, you can connect them with a nice straight line. Alright, so that's graphing using the intercepts. Two examples of graphing using the intercepts. We can also graph from a form of the equation that shows us the slope and the y-intercept. So let's look at that. This one shows us, the instructions say graph using the slope and the y-intercept, and the form of the equation shows us the slope and the y-intercept. So the routine for this is to first mark the y-intercept. Remember, -4 is the b value of the y-intercept, or it's the y value of the y-intercept, so we're going to mark -4 on the y-axis. And then we're going to use the slope, 2/3, to rise then run to more points. Since it's a positive fraction, we know the line will go up, and the units would be 2 up over 3. So from the point we marked, we go up 2 over 3, mark a point, up 2 over 3, we can mark several of those, up 2 over 3, and remember, if you need to go backwards on the line, you just reverse the stair step, down 2 and left 3, as many as you need to feel comfortable to connect your points. Okay, I would only need to see a few. Alright, that's graphing using the slope and the y-intercept from the equation. Let's look at another one of those. Let's graph this one using the slope and the y-intercept. Okay, the form of the equation shows us the slope and the y-intercept. So our y-intercept this time is 3, or 3 on the y-axis. The point 0, 3 is this point, 0, 3. And since our slope is negative, we know that the line is moving down left to right. So the change in y values is going to be 5, or -5. Change in x values is going to be 2. Our rise over run is -5 over 2. So from the point we marked, down 5, 1, 2, 3, 4, 5, over 2, 1, 2. And again, 1, 2, 3, 4, 5, over 2. And if you need to reverse it, up 5, and backwards 2, or to the left 2. Just a few points there so that you can confidently connect them with a straight edge. Alright, then we graphed from the equation using the slope and the y-intercept. Okay. This is a little out of order from the way the book covered it, but I want to go ahead and graph linear inequalities here because we use the same skills with the extra steps. So, to graph this linear inequality, remember this is very much like y equal mx plus b, except that it's y is less than mx plus b. Remember, we can find our points, the y-intercept and rise run, to more points the same way we do for equations. So let's mark points for y is equal to -2x plus 3. So our y-intercept is 3, 0, 3, and our slope is -2, so we know that in fraction form that would be -2 over 1. Negative slope means the line moves down, so down 2 over 1, down 2 over 1, down 2 over 1, and as many of those as you like. Go in reverse if you want to. Now, because this is an inequality, remember we need to decide on line style. Okay, so the style here is dashed. Okay, because we don't use a solid line because there's no or equal to. So we're not going to show a solid line connecting the dots, but a dashed line. Okay, so a dashed line connecting your points. Now we need to test for shading. Now remember, this half of the graph, all of the points over here will either test true or false. All of the points over here will either test true or false. They'll test the same way. So all we have to do is test 1 point on this side or 1 point on this side. We're going to shade with the true points. And remember that if 0, 0 is not on our line, that we can use it for a test point. So let's test 0, 0 for shading. Alright, so we're going to test the point 0, 0. So in the inequality, y is less than negative 2x plus 3, we're going to put zero in for y and 0 in for x for the point 0, 0. So we have 0 is less than, 0 times anything is 0. 0 is less than 3. Now we need to decide if that's true or false. Did 0, 0 produce a true statement or a false statement? 0 is less than 3 is true. So that means 0, 0 is in the section where we want to shade. If it's true, all points in this section are true. So because 0, 0 tested true, we're going to shade this portion of the graph. Okay, let's do one more of those. Okay, graph this linear inequality. Now notice this one is not in the form where we can see the slope and the y-intercept yet, but we could quickly add 3x to both sides. So let's do that quickly. Y is greater than or equal to, let's add 3x to both sides, 3x minus 4, with our minus 4 that's already here. Now, minus 4 is the y-intercept, negative 4. The slope is 3. It's a positive slope. That means the line goes up. In fraction form, 3 is 3 over 1. So up 3 over 1. Up 3 over 1. Several of those until you feel comfortable. And backwards if you need to. Marking your points. Now, what about the style? Okay, for this inequality symbol, it's a solid line because it includes the or equal to. Okay, the or equal to. So it's solid. Okay, and now we need to test for shading. So again, conveniently, 0, 0 is available for testing. So let's take 0, 0 to test for shading. Okay, so in the original inequality, negative 3x plus y is greater than or equal to negative 4. We're going to replace both x and y with 0. Negative 3 times 0 plus 0 is greater than or equal to negative 4. 0 times anything is 0, greater than or equal to negative 4. 0 plus 0 is 0, greater than or equal to negative 4. And now we need to decide if this is true or false. Is 0 greater than a negative number? Again, this is true. Okay, true. 0 is greater than a negative number. The two examples we've done, our test point came out true. Does that always happen? No. If the test point comes out false, we don't shade with the test point. In this case, the test point came out true again, which means all the points with 0, 0 make the inequality true. So we're going to shade with 0, 0. Okay, shade with 0, 0. Okay, so you could prove it by picking another test point and making sure that it comes out true also.